Hello viewers, in today's session we are going to discuss an important concept in three-dimensional geometry, that is the image of a line with respect to a plane, right? So here we'll see the concept of how to find the image of a line in a plane with the help of this problem. So here we have to find the image of this line whose equation is given as x minus 1 over 3 is equal to y minus 3 over 1 is equal to z minus 4 over minus 5 with respect to this plane 2x minus y plus z plus 3 is equal to 0, right? So here the direction ratios of the line are given as 3 1 and minus 5, and the direction ratios of the normal to the plane are given as 2 minus 1 and 1, because here the direction ratios of the normal to the plane are given by the coefficients of x, y and z. So here we have 2 minus 1 and 1, right? So let us see how we can find out the image of this line when this plane acts as a mirror, right? So let us start. So now here there is an important observation about the line and the plane P, right? So this is our line L and this is our plane P. So the direction ratios of the line L are given by 3, 1 and minus 5, and the direction ratios of the normal vector to this plane P are given by 2, minus 1 and 1. So now if we find out the sum of the product of the direction ratios of the line and the normal vector to the plane P, then we can find that 3 times 2 plus 1 times minus 1 plus minus 1 times 1 is equal to this is 6, this is minus 1, this is minus 5. So we have 6 minus 6 is equal to 0, right? And this suggests that the line L is parallel to the plane P, right? Because see, here we have the plane P and this is our normal vector and this is our line L, right? So this normal vector is perpendicular to this line L, because here it satisfies the condition for perpendicularity, that is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So the normal vector is perpendicular to the line L, and to get the image of this line L with respect to this plane P, suppose the line L has the image that is L prime, then the concept of parallelism of the line L, P and L prime is used here. So now consider a rough diagram here. Suppose this is the plane, and let us consider the line whose image is to be determined. Suppose this is the given line, right? So suppose this is our line L and this is our plane P, right? Okay, now the image of this line L in this plane P may be drawn like this, right? And this is the image line. So let us denote this image line by L prime, right? Now the concept is that this line L P, the plane P and this image line L prime are parallel to each other, right? So now consider the normal to this plane P, right? And let us draw the normal like this, and this is our normal, that is n vector, right? And here we have the point say M, where this normal intersect this image line L prime, and N is the point where this normal intersect this line L, right? And M, here we can take another point, say O, and O is the midpoint of this segment, that is NM, right? So this is an important concept, right? So M is the point where this normal N, it intersects L prime. N is the point where this normal intersect the line L, and O is the midpoint of this segment NM, because the line L and the image L prime are equidistant from the plane P. So now let us write the equation of this normal n vector, right? So the equation of this normal vector n may be written with the help of the equation of this line L, right? Now see, this normal, it also intersect this line L, right? And L passes through this point, that is 1 comma 3 comma 4, right? So this is the point 1 comma 3 comma 4 which lies on this line L, and the direction ratios of this line L are 3, 1 and -5. So the direction ratios of this normal vector are given by the coefficients of x, y and z. So here the direction ratios are 2, -1 and 1, right? So utilizing this point, we can now write the equation of this normal vector as x minus 1 over 2. Then we have y minus 3 over -1, and then we have z minus 4 over 1. So 2, -1 and 1 are the direction ratios of this normal vector, and this normal, it passes through this point, that is 1 comma 3 comma 4, which is also a point lying on this line L. So now the next aim is to get the coordinates of a general point lying on this normal vector n, right? And we can take that general point as this point M, right? So for to get the coordinates of this point M, which lies on this normal vector as well as on this image line L prime, we can take here a scalar. Let us call the scalar as lambda, right? So we can now form three equations. So we have x minus 1 over 2 is equal to lambda, y minus 3 over -1 is equal to lambda, and then z minus 4 over 1 is equal to lambda. So solving these three equations for x, y and z, we have x is equal to 2 lambda plus 1. Then we have y is equal to minus lambda plus 3, and here we have z is equal to lambda plus 4, right? So the coordinates of this point M may be taken as 2 lambda plus 1, then we have minus lambda plus 3 and lambda plus 4. So now the situation is that the coordinates of this point M are given by these numbers. The coordinates of this point N are given by 1 comma 3 comma 4, and now O is the midpoint of this segment NM. So O is the midpoint of this segment NM. So using the midpoint formula, we can now write the coordinates of O as here we have 2 lambda plus 1 minus lambda plus 3 and lambda plus 4, right? So we have x1 plus x2 over 2, then we have y1 plus y2 over 2 and z1 plus z2 over 2. So this is our midpoint formula. So now x1 y1 z1 may be taken as this coordinate, and x2 y2 z2 may be taken as this coordinate. So we have 2 lambda plus 1 over 2, then we have minus lambda plus 3, plus 3 over 2. Then we have lambda plus 4 plus 4 over 2, right? So simplifying, we have 2 lambda plus 2, and here we have 2. Then we have minus lambda plus 6 over 2, and this is lambda plus 8 over 2, right? So these are the coordinates of the midpoint of NM, and we can see that this point O, it lies on this plane P, whose equation is 2x minus y plus z plus 3 is equal to 0. So this point O must satisfy this equation. So now substituting this coordinate in this equation, we can find out the value of lambda. So now we have 2 times x is 2 lambda plus 2 over 2. Then we have minus y is minus lambda plus 6 over 2. And then we have z is lambda plus 8 over 2. And here we have plus 3 is equal to 0, right? Now multiplying throughout by 2, we can get rid of these 2's. So we have now 2 times 2 lambda plus 2 is 4 lambda plus 4. Then we have minus minus plus. Then we have minus 6. And then we have lambda plus 8. And here 2 times 3 is 6, right? So this is a linear equation in lambda. We can easily solve it. So this is 4 lambda plus lambda plus lambda, that is 6 lambda. And here this 6 and this 6 get cancelled. So we have 8 plus 4 is 12 is equal to 0. So 6 lambda is equal to minus 12. So lambda is equal to minus 2, right? So the value of this scalar lambda is equal to minus 2. So now substituting lambda is equal to minus 2 over here, the coordinates of the point M are given by 2 times minus 2 plus 1. Then we have minus minus 2 plus 3, and here we have minus 2 plus 4, and the coordinates are minus 4 plus 3 is minus 3. Then we have 3 plus 2 5, and here 4 minus 2 is 2, right? So the coordinates of M are given by minus 3 comma 5 comma 2. So now the equation of this image line L prime can be written with the help of this coordinate M, because this point M lies on this line L prime. So we have now x minus minus 3, and then we have y minus 5, and then we have z minus 2, right? And the direction ratios of this line L prime are same as the direction ratios of this line L, because the lines L and L prime are parallel to each other, and we know that parallel lines have proportional direction ratios. So the direction ratios are 3, 1 and minus 5. So the equation of this line L prime is given by x plus 3 over 3, y minus 5 over 1, and z minus 2 over minus 5, right? So this is the equation of the image of this line L with respect to this plane P. So now further, if we have to find out this the distance between the line L and the image line L prime, then we have the point N as 1 comma 3 comma 4, and the point M is now equal to minus 3 5 and 2, right? So to get the distance NM, we can make use of the distance formula. So we have x2 minus x1, that is minus 3 minus 1 square, and here we have 5 minus 3 whole square, and then we have here 2 minus 4 square, right? So this is square root of minus 3 minus 1 is minus 4, minus 4 square is 16, then we have 2 square is 4, and here minus 2 square is 4, right? So this is 4 plus 4 8, so this is 16 plus 8, that is 24, and square root of 24 can also be written as 2 times square root of 6, right? So the distance nm is given by 2 root 6 units.